Hi, good morning students. Today we are going to give introduction to the second lesson in 10th standard physics, namely magnetic effects of electric current. I hope you are all familiar with the use of magnets in our everyday life. You must all have heard and used magnets. Yes, let us now ask a question. What is a magnet? The moment we say about a magnet to anyone, they will come to know that the bar magnet, horseshoe magnet, magnetic needle, magnetic compass and all. Where are these magnets used in our everyday life? Most of the everyday applications in our life such as the speaker in a radio or television, the laptop memory, the pen drive, like that there are so many other applications of magnetism in our everyday life. But what is the history of the invention of the magnet? So in your primary or in the secondary classes, you must have heard about the history or the story of the discovery of the magnet. There was a shepherd in the continent Asia, in a place Asia Minor, that is Magnesia is the actual location of the place in Asia Minor. So a shepherd was having an iron pole and he was casually digging in the ground and that iron rod was pulled. So he was astonished that some force is pulling the rod to some extent. Then he found by digging inside the ground there were some huge stones. So these stones only tried to attract the iron pole which was had by the shepherd. So this was a tale behind the invention of the magnet, and such stones which were naturally occurring inside the earth's crust were the first magnet. Okay, these are all natural magnets. Then that stone was taken by the Chinese and put to test. It was suspended by a string from the ceiling. It was always turning around and finally showing the directions north and south exactly. So the Chinese put the stone into use as a mariner's compass. Okay, so we have come to know there are two properties for the magnets. So what is a magnet means? Roughly we can say that magnet is a substance which attracts iron or some other materials like iron. Second, magnet is also a substance which when suspended freely, it is always showing the directions north and south. So these are the two basic properties of the magnet. Magnet has two properties. So what is the first property? Means it is attraction or attractive property. Okay, attractive property. And what is the second property? When it is suspended freely means it shows the direction. So that is called as what? A directive property. So these are the two basic properties of a magnet. And I told you that it was first, it was first discovered by a shepherd in a place called as Magnesia. Magnesia in Asia Minor. In Asia Minor. So this is why the substance was called by the name magnet. This is one story only. But actually, what is the reason for calling that attracting substance as a magnet is slightly different. The scientists took that naturally occurring magnetic stone and put to test that it contained iron ore. Okay, so the iron ore, which was named as magnetite. Magnetite. So what is the name of the iron ore which is responsible for the property of attraction and showing the direction? It is the iron ore called magnetite, and its molecular formula is Fe3O4. So Fe is iron, O is oxygen. So it is a mixture of iron and oxygen in a proportion 3:4. So this compound Fe3O4 is called by the name magnetite, and this only is the naturally occurring magnet. And the two types of magnet, now we can call them as what? One is naturally occurring magnet, okay, natural magnet. This natural magnet was named as lodestone. Lodestone. So the stone containing Fe3O4 which attracted iron pole of the shepherd. Oh, that only was called as what? Lodestone. And today what type of magnets we are using? There are artificial. Okay, there are artificial magnets. So these artificial magnets which we are using in our everyday life have different shapes, size according to the need and requirement. Okay, so for this example I can take bar magnet. Okay, then horseshoe magnet, bar magnet, horseshoe magnet, then the magnetic compass. These are some of the examples for what artificial magnets. So magnet in general is a substance which attracts iron filings or any other substances similar to that of iron. And a magnet is a substance which will show north-south direction clearly when it is freely suspended. And the naturally occurring magnet contained iron ore, namely magnetite. This is why it got the name as magnet. And the name of the natural magnet is lodestone. What component is present inside is iron oxide only. Okay. Now what type of magnet is very familiar to all of us? That is a bar shaped magnet, which is called as a bar magnet. So I will consider the case of a bar magnet first. Okay, the bar magnet. Now this is an artificial magnet. Bar magnet is an artificial magnet. So the shape, bar shape is given by us. So it is an artificial magnet. Mostly its shape will be like a rectangular parallelepiped bar like this. Okay, this is a bar magnet. Now let us consider this is the bar magnet. Suppose if you bring this, an iron nail. Okay, if an iron nail is brought towards one end of the bar magnet, it will stick to it. So this is an iron nail. Suppose if the iron nail is brought very close to the other end, then also it gets stuck to this end. So these two ends are attracting with a much greater force. Suppose if the iron nail is brought near the middle or center of the magnet, means there is not much attraction. Sometimes there will be no attraction even. Okay, sometimes. So it is found that the attraction is maximum only at the two end points of the magnet, and these two end points where the attraction by this nail, okay, is maximum. These are called the magnetic poles. So this is one pole and this is another pole. So pole is that the end of the magnet where the attraction by this iron nail is maximum. Okay, what will happen if such a bar magnet, suppose if a bar magnet is suspended, okay, if it is suspended freely. Okay, this is freely, and one end will be pointing towards the geographic north. One end is pointing towards the geographic north. Okay, this is a geo north, and the other end is pointing towards the geographic south. Okay, suppose you take this is the earth. The earth is spinning about an axis which is passing through the geographic north and the geographic south of the earth. So this north-south, this is the axis of rotation of the earth. Suppose if a magnet is suspended, means the suspended magnet will be pointing like this. It will not align itself exactly along the north-south axis. It will be tilted. That in a higher class only you are going to study why the reason for the tilt and all. But at least you should know that one end of the magnet which is pointing towards the geographic north is called the north pole of the magnet. And the other end which is pointing towards the geographic south pole of the earth is called as the south pole of the magnet. So one end of the magnet I can say this is north and the other end can be called as the south pole. So any magnet will have how many poles? There are two magnetic poles. One end of the magnet where the attraction is maximum and which is facing towards the geographic north of the earth is called as the north pole. And the other end of the magnet where the attraction is maximum and which is pointing towards the south Geographic south of the earth is called as the south pole of the magnet. Okay. So a bar magnet has how many poles now? 2 poles. So pole may be defined as that end of the magnet wherein the attraction or repulsion also is maximum. In this case, nail will be always attracted. What will happen if any other magnet is brought closer to this magnet? Either it may be attracted or repelled. And this force of attraction or repulsion will be maximum only at the 2 ends. This is why we are defining what a magnetic pole is defined as that end of the magnet at which either the attraction or repulsion force will be maximum. And every bar magnet, any magnet will have only 2 poles, namely the north pole and the south pole. Okay. Now there are some other experiments based on these bar magnets. One such experiment I will tell you. You see here. Suppose if you are given 2 materials, 2 identical materials made up of the same material, okay, 2 identical devices, okay, both are rectangular shape, bar magnet shape. So let us take that this is A and this is B. 2 materials, both are painted red color, let us say. Out of this A and B, one is a bar magnet and other one is a simple iron bar, which is not a magnet. A and B are 2 materials I told you. One of these 2 is a bar magnet and the other one is simply a bar, which is not magnetized. But I don't know whether A is a magnet or whether B is a magnet. Only 2 materials are given to us. How to identify? So for that one method is there. So first I will take the material, that is A. Okay, first material I will take that is A. Okay, and another material B is touched near the one end of A. So B is brought perpendicular to A and it is touched at A. Okay, it will be attracted. And suppose if it is brought to some other position, new position, here also it is experiencing the same attractive force. And here when it is kept at the center or when it is shifted to the other end, then also the force of attraction between these 2 A and B will be the same force of attraction, means then B is a magnet and A is a iron bar. Understand? Suppose when B is placed at this position, first position, you find the attraction. Okay, when this attraction is more, but when B is kept at the midpoint and there is no attraction or very less attraction, and then once again when B is placed at the other end, then again more attraction is found, means in that case A is a magnet. So have you understood? This is how to identify which of the 2 materials is a magnet and the other one is a plain bar of iron. So I am going to the next topic. I am going to rub the board. Have you understood up to the basic concepts? So what is a magnet? Magnet is a substance which has 2 properties, namely attractive property and this directive property. Whenever I say attraction, naturally repulsion also may be included, but repulsion is not taking place in the case of a bar magnet and the iron. That is why I am saying in terms of attraction only. Okay, so the 2 properties that is of a magnet are what? Attractive property and the directive property. And the name magnet was derived, one is from the place where it was found is magnesia, and the second one is it is an iron ore, magnetite. Okay, and there are 2 types of magnets, namely the natural magnet and the artificial magnets. Some of the interesting differences, if you want, means I will tell you. Natural magnets they do not have a definite shape, while artificial magnets have a definite shape, like the bar magnet, horseshoe magnet. The natural magnet is having a fixed strength, whereas the artificial magnets we can give a great strength. Even these magnetic cranes and all can be used to lift heavy trains and all. That much strength we can give artificially. So bar magnet has how many poles? There are 2 poles. Okay, and if you suspend a bar magnet, means vertically, then this alignment of the bar magnet is along the axis of the earth. So one end of the magnet which is pointing towards the geographic north of the earth is called the north pole of the bar magnet, and the other end of the magnet facing the south of the earth is called as the south pole. Okay. Now some other interesting factors we are going to study. Be ready. Now let us discuss from where does this magnetic power is coming into the bar magnet. Who is responsible for the attraction and repulsion by the bar magnet? What is attracting the iron pieces towards the bar magnet? We are going to discuss, and the topic is atomic theory of magnetism. It's very simple. I have considered a bar magnet having two poles, north and south. Now what will happen if it is cut at the center? It will become two pieces. Okay. So what we get is what? Two pieces, and both the pieces will again act as bar magnets only. So the two pieces which I have cut from the magnet, no, both of them will act as bar magnets, and each magnet will again get what? North and the south pole. Now you tell me what will happen if I will cut these two pieces once again into half. How many magnets we will get? 4 magnets. So each piece will also now behave like a bar magnet. So that 4 bar magnets we will be having, and each magnet will again have a north pole and the south pole. Like this, you imagine how long we can go further by cutting each piece into two like that. Suppose if these are also cut into 2 pieces, finally what will be the final piece? The final piece will be a small atom. The final piece is an atom. Okay. So this is an atom, and this atom is having a positively charged nucleus and negatively charged electrons which are revolving around the nucleus. Okay. So these are all the electrons. Okay. Like that, in different orbits, electrons will be revolving around the nucleus. So the final piece, by breaking the magnets into the last infinitesimally small piece, will give you only a single atom. And you should know that the single atom also will have a north pole and a south pole. Okay. So this also will be having a north pole and a south pole. So how is it possible? Who is giving magnetism to the atom? The secret of magnetism I am going to tell you. What is the secret of the magnetism of a bar magnet? By breaking it till to the final end piece called an atom, the atom is also having a north pole and the south pole. This is because who is contributing to the magnetism of the atom is the electrons. The electrons are very, very small fundamental particle, isn't it? And its mass is negligibly small. But still, these electrons only are contributing to the greatest magnetism observed in the bar magnet and the other magnets. Okay. So the electrons are responsible for the magnetism. The electrons have 2 types of motion. Okay. Electrons have 2 types of motion. And what are the 2 types of motion the electron has? How does the electron move inside an atom? It is spinning about itself. It is spinning, okay, rotating about an axis. And also it is revolving around the nucleus. Just like the planets spin about themselves and also revolve around the sun in the solar system. So the electrons are also spinning about themselves. This is called as a spin motion. Okay, first one is what? Spin motion. And the second type of motion is called as orbital motion. So orbital means it is coming around the nucleus. So the first type of motion is what? A spin motion, and the second type of motion is called as what? The orbital motion. Okay, because an electron is moving, either spin motion or orbital motion. Okay, whenever an electron is moving, this movement of the negative charge will produce a current. Okay, whenever charges, electric charges will undergo any type of motion, they will have a current associated with them. And whenever a current is produced by the moving charges, a magnetic field also will be produced. This is the very, very important secret of magnetism, my dear students. Suppose if an electron is not at all moving, means then this electron will be surrounded only by an electric field. Suppose if the electron is moving means then it is also associated with the magnetic field in addition to an electric field. So moving charges produces a current, and this current produces a magnetic field, and because of the two types of movement of the electron only, every electron is possessing some magnetism. We are all thinking that only iron is used for making magnets, only the iron atom is having magnetism. Is it not? It is not like that. You take, for example, you take copper, okay, copper atom, one atom of copper you take, one atom of aluminium, okay, one atom of aluminium, and one atom of iron you take. So three atoms I have considered: copper, aluminium, and iron. Do all these atoms made up of positive and negative charges? Do all the atoms have a positively charged nucleus? Okay, so this also is having a positively charged nucleus and the revolving electrons in various orbits. Similarly, the aluminium also, okay, like this, all these electrons are revolving around the positively charged nucleus in various orbits. So, I have considered three atoms. One is copper, second one is aluminium, and the third one is iron. All these will have electrons revolving around the nucleus. I will consider the electrons present in the copper atom, and also I will consider the electrons present in the aluminium atom. Similarly, the iron atom. So, do you agree with me that the electrons revolve around the positively charged nucleus in all the three atoms? Yes. The electrons are the same mass, the electrons are the same charge, same size in all the three atoms. But what is the difference? I am going to tell you now only. Okay. Now, for example, I will take the electrons present in the copper. Okay. Now, due to the orbital motion of the electron as well as the spin. Spin means what? This electron will spin about itself like this. Okay. It is going to spin. It may spin in the clockwise direction or in the anti-clockwise direction. Similarly, the orbital motion of one electron will produce a magnetism, while the orbital motion of the other electrons need not have the same value. Understand? That means the orbital motion of one electron may orbit in this plane, while the other electron may orbit in some other plane. So that the magnetism produced by the different electrons, when you add, the net magnetism will be equal to 0. Each electron will 100% possess magnetism. That is called as magnetic moment. In the later stage only you will study that. Magnetism, the strength of magnetism is expressed by magnetic moment. So each and every electron will certainly possess a magnetic moment. One electron is having plus 5 units. The other electron is having minus 5 units. One third electron is having a plus 2 units of magnetism. Fourth electron is having minus 2 units of magnetism. When you add plus 5, minus 5, plus 2 and minus 2, what will be the net? Total is equal to 0. Like that, if you add the magnetic moment of each and every electron in this copper atom, the net magnetism of the entire atom is equal to what? 0. Understand? The net magnetism of the entire atom is 0. But do every electron possess magnetism or not? It is there. Understand? So every electron, irrespective of any atom like copper, aluminium or iron, every electron will have what? A magnetic moment, magnetic strength. But in the copper atom, when you add the magnetism of all the electrons, then they will cancel each other, and the net magnetic moment of the atom will be equal to what? 0. In aluminium atom also, suppose if you take the electrons, each electron's magnetism, if you add the magnetic strength or magnetic moment of all the electrons present in aluminium atom, it will not be equal to 0. It is not be equal to what? 0. But there will be some minimum magnetism remaining. Understand? So just like plus 7 and minus 5 are added, means what will be the difference? 2. 7 minus 5 is 2. So plus 7 and minus 7 are added, means what? It will become 0. That is happening in the case of what? A copper atom. Okay. Whereas in aluminum atom, each and every electron will possess some strength of a magnet. That is a magnetic strength. That is called as magnetic moment. If you add all the magnetic moments of the electrons present in the entire atom, it will not cancel entirely, but minimum magnetic moment will be still remaining. That is called non-zero magnetic moment. Whereas in iron there is a very strong union. There is a strong cooperation among all the electrons. So every electron will have a magnetic moment as copper and aluminum also are having. But they won't cancel each other. This is why best example for unity is strength iron, I can say, because all the electrons will have the same direction of the magnetic moment. If you add means all the magnetic moment of the individual electrons will be in the same direction, so that what will happen? There will be a very strong magnetic moment for the iron atom. See, electrons are of course present in every atom. But in the copper atom, if you add the magnetic moments of all the electrons, they will cancel each other and become zero. And in aluminum atom, if you add the magnetic moments of all the electrons, it will be non-zero, but very minimum. And in iron, if you add the magnetic moments of all the electrons, it will be non-zero and extremely high magnetic moment. Understand? That is why there are different types of magnetic substances in the higher studies you are going to study. This type of substances, now they are called as diamagnetic substances or diamagnetics, and this type of substances are called as paramagnetic substances or paramagnetics, and this type of substances are called ferromagnetic substances or ferromagnetics. See, this is just an introduction I am going to tell you, just to keep it in your knowledge, that is enough. This question and all will not be asked in the board examination and all, but in higher level it will be definitely asked. So, why I am saying means, in general, the secondary students are thinking that only iron atoms can be magnetized, iron atoms only possess magnetism and all. It is not like that. There are so many other atoms, they also possess magnetism, positive magnetism, negative magnetism, like that, many are there. Therefore, you must know at least that magnetism is not pertained only to iron atoms, it is pertained to all atoms, the solids, liquids and gases. See, for example, water. Water is a liquid. Water also is an example for what diamagnetic substances. Water and copper both are behaving in the same way. Understand? So, these are the three types of magnetic substances. Okay. And you must know that this copper is diamagnetic, aluminium is called paramagnetic, and iron is called ferromagnetic, which can be strongly magnetized. That is the ferromagnetic substances, because the magnetic moment of all the individual electrons, they get added up. And in the case of copper or diamagnetic substances, if you add the magnetic moments of all the electrons, it will become zero. So this is maximum in ferromagnetics and zero in diamagnetics. So in the intermediate must be what? That is paramagnetics. Understand? Okay, students, now you must have understood the atomic theory of magnetism. Now the next definition is what? Magnetic field. We are going to define this very, very important definition. What is meant by magnetic field? Very simple. Suppose you take a bar magnet, okay? Suppose you take a bar magnet and it is having a north pole and a south pole. You take a small iron nail, okay? Small iron nail and place at this much distance, very long distance. For example, the bar magnet is placed in the left hand and iron nail is placed in the right hand and at this much distance, long distance. Can you feel any attraction now? Not at all, because they are far separated. You try this at home. Bring the pin to a closer distance. Now also no attraction. Then little more reduce the distance. You will feel that some movement is experienced by the iron nail. Okay. Then again bring the nail so closer. You will feel that something is strongly pulling the iron nail. And still very close if you keep, it will jump on its own. Is it not? When you kept at a very long distance, it was not at all attracted. And slowly when you reduce the distance, what is happening at one point? At one point you are able to realize, that some force has started to act on the iron nail. That point where the magnetism is realized by the iron nail, no, that region onwards, there is something surrounding the magnet. There is something surrounding the magnet. There is some region or space surrounding the magnet, inside which any other magnetic substance like iron nail or safety pin will experience a magnetic force. So there is some region surrounding the magnet inside which the influence of the magnet can be experienced. So like that, suppose if the pin is brought a little more close distance, and I find that after reaching this distance and inside this only, I am able to experience the magnetic force. So this region or space surrounding the bar magnet or any magnet only is called as the magnetic field. So how to define it is the space. It is the space surrounding the magnet. It is the space surrounding the magnet. Okay, and inside this, okay, inside which any magnetic substance will experience a force. Okay, experience a force of attraction. This is called as magnetic force of attraction. So I will read once again what is magnetic field. Magnetic field, it is defined as the space surrounding the magnet. This is a space surrounding the magnet inside which any magnetic substance will experience a force of attraction. So I told you that if the pin is kept outside the magnetic field, means it will not be disturbed at all. Okay, but when it enters into that region of the magnetic field only, it will be attracted. Have you all understood? So next we are going to do a very simple experimental demonstration with the bar magnet. Be ready for that.